Hey there, welcome to a video discussing section 5.5, which will be on polynomial division. So we're doing section 5.5 on polynomial division. So far we've done polynomial addition and subtraction 5.3. I didn't really have a lesson for that, I just had you guys do some problems just to practice combining like terms. We did, of course, polynomial multiplication with that as well, where you're foiling. We did some factoring in 5.4. 5.1 was doing some exponent stuff, and 5.2 was on end behavior with graphing of polynomials. So now we want to add another thing to our toolkit. How do I actually divide polynomials? There are two ways you can do it. One way is going to be called long division, and another way, which I'll do over here, is called synthetic division. Polynomial long division is a little bit painful. Let me set it up for you. And before I actually go through the process, you may want to do this in the margins or somewhere else, but I'm going to open kind of a new sheet here. Let's say, for example, 457 divided by, say, 5. So if you remember doing this, many years ago, you first ask yourself, how many times does 4 go into 4? It doesn't. So how many times 5 go into 45? 9 times. Then we multiply 5 and 9 to get 45. Then we subtract, which of course is 0, and bring down the 7. How many times 5 go into 7? Once. 5 times 1 is 5. So you put the 5 there. 7 minus 5 is 2. And that's a remainder. Another way we can actually express is 91 plus 2/5. Whatever remainder is, you always want to divide it by what you're dividing, your divisor or whatever you call that on the outside. Actually becomes 91.4 if you did that in the calculator. So that's just a review of long division, which again should be some review, right? So we're going to do something kind of similar here. What you're going to want to do is focus on the leading term and the x cubed term there. And your goal is to ask yourself, what do I multiply to x to get to x cubed? Hopefully you realize it's x squared. Again, x times x squared is x cubed. Just like we did over here, right? How many times 5 go into 45? 9 times. How many times x go into x cubed? X squared times. Then notice how we, did 5 times 9 is 45, we brought it down. So you can do something similar here. You're going to multiply x squared by x minus 2. So you've got to multiply x squared by x minus 2. So it's x cubed minus 2x squared. And then you're going to subtract. Now I'm going to surround this in parentheses, just to be careful. X cubed minus x cubed is 0. 6x squared minus negative 2x squared is 8x squared. And bring down to negative 5x. Just like we did back in the day where, you do bring down the 7. 5 times 1 is 5. And so, of course, you bring that down. So now we have to ask ourselves, what do I multiply by x to get to 8x squared? Hopefully you realize it's 8x. So again, you're focused on the leading term, the x minus 2. Focus on the x. X times 8x is 8x squared. So you have 8x squared, and then multiply negative 2 by 8x, which is negative 16x. So just very similar to the long division that we did back in the day. Work that out, that's going to be 11x, because you're doing a negative 5 minus negative 16. Bring down negative 8. And then you got to do multiplication one more time, be plus 11. 11x minus 22. The remainder, I think, is 14. And your right is plus 14 over x minus 2. So really what we've done is figure out a way to re-express this expression. So that's what we were working on originally. X cubed plus 6x squared minus 5x minus 8 divided by x minus 2. It's the same thing as saying that. Now there is an advantage to actually knowing how to do this. It's not going to be very clear disadvantage until we get to chapter 8. So we are going to revisit this later in the spring. But this is something we need to add to our toolkit. Now, this is probably not the most pleasant experience. There's actually a better way of doing this division, and that's synthetic. Let me show you synthetic division down here. Here's what we do. I'm going to draw like a rotated L, or I could like think of like half of a box. I'm going to put my coefficients of the big polynomial in here, and I'm going to put a 2 on the outside. 2 is a 0 of x minus 2. So whatever makes the denominator 0 is what we're going to put right here. Because x minus 2 is our denominator. So I'm going to put a 2 right there. And the coefficients I'll put in here. Now, by the way, there's a little note. You want to put a 0 if the term is skipped. And what I mean by that is that what if there were not a negative 5x? What if it was x cubed plus 6x squared minus 8? Then I would have to replace the negative 5 here with a 0. But of course, that's not the case, so we don't worry about that for now. Now, how does this process work? What you do is you bring the 1 down, and you multiply 2 times 1, which is 2, and you put a 2 right there. Then you add these two numbers, which is 8, multiply 2 by 8, you get 16. Then you add these two, which is 11, multiply 2 times 11, which is 22, and you get 14. Does this look familiar? Hopefully it does, because it's the same thing as what we got from the long division process. Basically, these are the coefficients of your quotients. The quotient's the result you get when you do division. But you always have to realize that, okay, I start with x cubed, so now this goes down by 1 power, or 1x, which is x squared plus 8x plus 11 plus 14 over x minus 2. So it's actually a cleaner and more effective process than long division. So one would ask them, why use long division? Why not just use synthetic? That's because synthetic doesn't always work. This only works if dividing by something that follows its form, x minus a. So if the coefficient of x is not 1, or if you have a nonlinear term like x squared or something like that, then unfortunately you can't do it. So like in the case of example 2, we can't really do synthetic division, but you could get a little creative, but I think we're just going to do long division just so you're practicing that skill. 2x plus 1, 4x cubed. You have to put a 0x squared minus 7x plus 2. So again, you're focusing on the leading term. 2x goes into 4x cubed, 2x squared times 4x cubed plus 2x squared, negative 2x squared minus 7x. 2x goes negative 2x squared negative 1 times. Sorry, negative x times. So negative 6x plus 2. That goes in negative 3 times. That'll be 5. To get plus 5 or 2x plus 1. If you wanted to use synthetic division, you probably could. What you would have to do is actually pull a 2 out of here and make it x plus half. And don't forget that you actually pull the 2 out. Put negative half, because that's what makes this 0. 4, 0, negative 7, 2. Remember, we skipped over the x squared term. Bring the 4 down, multiply that by negative half. That's going to be negative 2. Negative 2 multiplied by 1. -6, that'd be 3, and that'll be 5. But remember, because we had pulled a 2 out earlier, we're going to have to take half of our coefficient, so it becomes 2x squared minus x minus 3. But the remainder just stays as is. And of course, you divide by 2x plus 1. So you could kind of get away with synthetic division for that one. Now, unfortunately, you can't do synthetic division here. You really just have to do the long division. 3x4 minus 5x cubed. There's no x squared term, so got to put a placeholder for it, plus 0x squared plus 4x minus 6. X squared minus 3x plus 5. So what do you multiply x squared at 3x for? 3x squared, 3x4, negative 9x cubed plus 15x squared. Do it correctly, you should get 4x cubed minus 15x squared, and down to 4x. That goes in 4x times. So 4x cubed minus 12x squared plus 20x. I know. Those cancel, you get negative 3x squared minus 16x plus 6. That goes in negative 3 times. And then we kind of just stop there. And of course, you'll say plus negative 25x plus 21 over x squared minus 3x plus 5. So that's just another way of expressing this situation. 3x4 minus 5x cubed plus 4x minus 6 all over x squared minus 3x plus 5. So we'll actually be working this kind of stuff, and it's the same thing as saying that right there. One last thing before we end the video. So if the remainder happens to be 0, we haven't seen that yet. Every time we've done this process, either long or synthetic, we've had non-zero remainders. But if the remainder is 0, then x minus k, whatever you're dividing by, is going to be a factor of the function you're dividing into. So for example, if this is a factor of this, let's do synthetic division, 3, negative 4, negative 28, negative 16. We'll put a negative 2 on the outside because that makes that 0. Makes x plus 2 0. Drop the 3, multiply, add, multiply, add, multiply, add. So what this tells me is that x plus 2 times 3x squared minus 10x minus 8 is going to equal 3x cubed minus 4x squared minus 28x, minus 16, there we go, sorry about that. So it's a way of factoring, actually. And then I can actually take this further. If I do the diamond for this bit, negative 24, negative 10, negative 12, and positive 2. But I have to write it as 3x squared minus 12x plus 2x minus 8. X plus 2, x minus 4. And then my zeros will be all these points here. So what we'll do is we'll ultimately actually start graphing stuff like this, where I'll probably give you a factor, and then you have to use synthetic division to get the other factors, and you get the other x-intercepts. And now that we know about end behavior, we can actually add more to our toolkit and actually have these graphs that look more accurate. So that's kind of the direction we're going in with this stuff. And we'll spend a lot of time with synthetic division. Synthetic division is actually going to be our preferred way. So don't worry, I'm not going to force you guys to use long division too often, but sometimes we kind of have to do it. So that's why I wanted to go with you. Synthetic is obviously more effective and cleaner, and it's something that will be quite prevalent in pre-calculus. So it's good that we're doing this now. Okay, that'll end the video, and I'll see you guys later.